So welcome everybody to the October HPC Best Practices webinar. Today we're going to hear from Damien Lebrun-Grandié of Oak Ridge National Laboratory, who will be addressing the topic of sustainable HPC software, a maintainer's perspective. We want this webinar to be interactive, so we encourage you to ask questions. We prefer to do that with a Google Doc, and that way we can ask Damien to provide some written answers, and then we can publish that as part of the archives of the webinar. The link is on the screen, and I'll be putting it in chat periodically as a reminder as well. There will be some places within the webinar where it's natural to stop Damien and try to ask some questions if they arise. Otherwise, when we get to the end, we will have more of an opportunity for Q&A. And at that point, we may be able to open up the mics and things like that. Also, we would really appreciate your feedback on this webinar. And there's a brief survey at the link shown, the feedback link. Just a couple of questions that'll only take you a couple minutes to complete, but it's really helpful to us to understand how we're doing in reaching you, our audience, and helping you find resources for HPC scientific software development. And with that, I will turn it over to Damien.
Thank you, David. Thank you for the opportunity to speak. Okay. Okay. So before we dive into what I found were the core challenges, to sustain software, let's make sure we agree on a few definitions. So first, here is the working definition of software sustainability for this talk. So when I say software sustainability here, I really refer to the viability of the software project, viability and longevity. So, you need to be even thinking beyond what you think the lifespan of your project might be. So I don't think of sustainability in this talk as the energy efficiency, which is also an important subject, but it's not what we're going to tackle here. Hopefully, if you've read the abstract, that should be pretty obvious to you. So with respect to software sustainability, the three pillars are really adaptability. So the ability for your project to adapt to new architectures or new condition, new standard, new tool chain. The maintainability, so the ability that you will have to fix bugs and add new feature without breaking the functionality that you already provide. And then the resilience, which would be the fact that you could lose individuals and your project is not going to collapse. So, second. The talk is entitled "Some Perspective from a Maintainer." So maybe we should make sure we agree on what's a maintainer. So the maintainer is really the steward of the longevity of your project. It's your strategist. He is loosely aware of the entire project. He is really directing the orchestra between the developers, and so see developers as regular contributors and reviewers, which usually also developers, but that haven't necessarily worked on the feature. They help integrating some proposed contribution into the project. And so the maintainer is really the person that helped direct that orchestra. So it's not so much about writing code, more about facilitating. So the maintainer really, so you see on the right, the authority, it's not that you make decision. The important part is accountability. In the end, if things go wrong, this is going to be on you. So you have you try to manage a resource, you find reviewers when and if you can't, you do the review yourself, and you might eventually end up doing development if you can't find anyone or if there's some sense of urgency. So that's really what I mean by a maintainer. So here to enter a bit into sustainability. So one of our paradox in HPC is that everywhere we rely on software for advancing science, right? But the software doesn't really get resource or spotlight. It's somehow some artifact that happens, but really it's at the center, and so here to illustrate on the right, you see illustrating one of these facilities that we spin up, with some of the fastest supercomputer in the world, but we to run anything on it, we actually need software. And so this talk is going to be going a bit about what it takes to sustain such a foundational project, and discuss some of the major challenges. So here is the table of content for my talk. So I'm going to go over three, what I think are three major challenges for sustaining a project. So the bus factor, technical depth, and the Hyrum's law. And so hopefully by the end of the talk, you'll understand the cartoon if you don't already. But I'll stop along the way when we transition to all of them, so you'll have opportunity to ask questions on the various parts. So throughout my presentation, I'm going to draw example from my experience. So I've been, so the Kokkos library, so it's not a talk about Kokkos, but just to give you a bit an idea of where I come from. So Kokkos is a C++ performance portability library, so that lets you write single source code that you can use to run anywhere from your laptop to all the supercomputers that we develop. So the project has been going on for about 14 years. It's now really, depending on how you count, whether you want to count a more experimental project, it's about half a dozen to a dozen and a half repos. The main core project, which I'm the maintainer of, has about 250,000 lines of code. Over its lifetime, it had 162 contributors. So the number of contributors I wrote now is more the number of contributors on the entire Kokkos project, not just Kokkos Core. But Kokkos Core has regularly between 16 and 20 people that attend the meeting. So that gives you a bit of a feel that there is as many generation of people that work on this project, and it's been active for a while, and that can give you a hint of how I approach things. But to speak a bit to how used it is in our community. So at the end of the Exascale computing project that you might be aware of, that was this effort to get ready for the first Exascale supercomputers. Every other C++ software technology or application was using Kokkos to run on the various machines that we deployed. And to speak a bit to how much activity we have, like you can see the number of registered users on Slack or on GitHub. And in terms of publication, over last year, we got about 1 citation per day. So the point of this is so Kokkos, maintaining Kokkos. If when we mess up, people are not going to die, but we have enough people that rely on us that if we're careless, we will waste a lot of time for a lot of people that rely on us to be able to run their workflow. All right. So now we're going to go into the first core challenge, which I entitled bus factor. And so it's really about, you're going to see it's really about discovering how vulnerable your project might be and what are the points. And here you see a little bit the cartoon, which you might see coming. It's like discovering that some entities might be carrying a lot of the weight on your project. So the bus factor is something that's pretty known. I assume you guys have always heard the term, but let's go quickly over the definition before we extend and generalize. So it's really the risks that a single person would leave the project. So that's hit by a bus. What would happen if that person was hit by a bus that would halt or cripple the development of your project. So this is not just a joke. It's really something that can be a structural flaw on your project. So I don't know if you've ever seen this cartoon here. I'm changing a bit the meaning. They're referring to a dependency, but we build this castle of modern digital infrastructure. There's flagship application for mission critical simulations, and we are in fact often relying on some projects that are where the bus factor, the risk of losing a single person could really halt the project. So let's see a bit how you go about looking at this bus factor. So the way you would go about it, so you measure, so it's really about measuring how much your project depends on its most active members. And so what you would do on the left-hand side, you would get some kind of leaderboard where you count contribution from members, you rank them. So here the data that I have is not really important. This is aggregated data over the last year for the Kokkos project, so spanning many repositories. And so what you would do is you would look how many people it takes to reach some percentage of the work. So typically people will look at 50% of the overall contribution. So if by this metrics, the best factor for the full Kokkos project would be 6. So why does that matter? Well, it really shows a high risk if you have key contributors that weigh too much in this thing. This is really a risk on your project, right? So what I want to show you now is to not just stop at that. So the best factor, I assume you guys have always heard about it. There are other ways of looking at that. You need to vary a bit the granularity, and one important other information is dependence on organization. It's similar, right? Imagine that one of the organization would lose funding or change priority, and so for the same Kokkos data I had shown you before, these are the numbers. And so, for instance, you see that at the moment, over the last year, it just takes 2 organizations to go, over half of the activity. So why does it matter? So it really shows that you might be overly relying on single entities, and it doesn't mean that your project will collapse, right? If you only have one organization, but that's really also a structural weakness of your project. Okay, so so you shouldn't stop neither just at the contributor nor at the project level. What we really need to do is to get in the mindset of looking single failure point in your project. So what you would do is you would vary the granularity when you look at this data. So the data I showed what was at the project level. It gives you a good feel of what's happening overall, the overall health of your project. But you really, really need to dive into, take a lens and go closer and look at the sub package level, the core, the math libraries, what happened, how many developers do they have? These things might be varying very greatly. You need to go even further, and so when you know your project, you probably need to see at the module or component level You might have some critical part of your project that depends solely on one person. It can be a very high risk on your project. And if you really, really wanted to push it, you could go all the way to the file, the function level. Some providers, the notion of owners, that can be a formal way of, coupling part of your project to people. But sometimes it's more immaterial, and you might have some just knowledge on how things are done and how that are distributed across people, and that's another thing that you want to try to examine when you go and want to assess vulnerability of your project. So now I'm gonna draw some example from Kokkos. So don't panic. I know it's a lot of text, but I'm gonna go over it slowly. So the first one is kind of the obvious original thread, right? So Kokkos, I told you, has been around for 14 years, and we had 3 original developers, and 2 of them, have been gone. One of them was a PI, I think, has left up like 8 years ago. And the project managed to carry on, but it really makes you become aware of how fragile you might be losing these people who have had a very, very heavy influence on the design of your software, of your project. And so today, the reality is we are lucky enough that we have my colleague was still one of the original developer, but it's constant threat to lose somehow, not just the expertise, and so one of the lessons for it is you really, really need to proactively try to distribute this knowledge across people, try to document your decision so that you don't have to go back to the people that have been there the longest and ask them, why did we do it this way or whatnot? And so that's something like really in the Kokkos world, we've been trying to really actively do that. It's really convenient that we can always go to my colleague and ask him why are things this way today? But sometimes I swear that he just makes up answers anyway. So the lesson here is really you need proactively to work on decentralizing knowledge. So then, so we're going to go to the second thing is I picked up some stress tests we had like early on after I became maintainer of the project. So we had back-to-back 4 of our main senior developers that left to the industry. We have 3 left to Google and 1 to AMD. All of them left within 6 months. To give you an idea, so I'm saying senior developers, how important it was. One of them had just completed an entire overhaul of all our build system. We are going from hand roll make files to using CMake, and that person was leaving. So we knew how important it was, and we had, to mitigate the risk, we had involved like 3 people to, actively review and gain knowledge on it. But one of them was one of our designated backup left. So another thing that affected it with this, quadruple hit event is one high visibility sub-project, so a sub-module, if you will, or sub-repo, had one main person with a vision, and that was really maintaining it for years, left. And so the lesson is here, when things are very, very critical, like here, just think of what I was telling you, the build system. The build system is really kind of the backbone of your project, even more so on Kokkos that want to run on all these different architectures that have totally different toolchain. So for us, it's very, very central. So you really need to distribute knowledge, because you can actually multiple single points of failure at once will really endanger your project. Okay. So now let's go over mitigation strategy. I already mentioned some of them in the past, like when we were we knew about the build system and we're actively trying to mitigate that risk. So, so referring to the sub project where we lost the main developer. So it was a project. It's a tooling one in Kokkos, if you're familiar with Kokkos, which is really important. It's something we teach, right? But it's something that had in fact no testing in place. Not much of not so that's pretty bad, right? But one thing that saved us was that's a developer at the time had actually, when he worked at adding some new sub parts to this project, had taken the time to write design documents. He had actually been actively discussing this design with external consultants and whatnot. And so one of the success story for us was that one of the person that had been collaborating on this design of the auto tuning was able to come and take over some of that work and actually take it through the finish line. And we actually have a blog post like over last year on when we really landed the auto tuning feature in Kokkos. So the insight, the lesson from it is really you need to write down this design. The last example I'm going to take is because I really want you to encourage to not just think people, think really critical infrastructure. So one of the challenge, one of the other things I mentioned to build system is the testing infrastructure. So back when I joined the project, I'm hardly caricaturing, but we had one person that was really handling all the testing and the integration. So you can see the problem, right? Like that person goes on vacation or is sick, we are stalled. And so we have constantly and been really working hard at diversifying and trying to share the load across partners. So we have all sorts of solutions on premises at different partners or open source free resource, or we leverage some resource by the HPSF. So one of the things we've really worked hard at doing is trying to engage more developers. Even it's not because you have a good solution that you and that people hold the fort that you shouldn't actively try to involve more people if you think it's critical for your project. And so the lesson from this is really seek for redundancy in both people and systems. Okay. So the mitigation strategy for the bus factor really, in the end, summarizing is you should try to have something like mandatory reviewed documentation, both of the API or the decision for all new important things. The other actionable strategy, if you're not already doing that, you should really think seriously about enforcing code review. And as a maintainer, try to mix across teams and the individual to mitigate that bus factor. The third recommendation I would have is try to invest in documenting your processes and create a clear path for newcomers so that they can, become developers and later, hopefully replace you and be a maintainer. So it's really the idea of growing the bus. So it's not just about survive, you really need to decentralize knowledge and grow the contributor pool. So I'm done with this part of the talk. David, are there questions that I should address at this point?
Yeah, there are actually a couple. So the first one is, how do you think about the bus factor with respect to continued funding? For example, many funding sources support new features for scientific value rather than software maintenance. Should one try to track funding sources of contributors? Should PIs and funders be counted in the bus factor?
Yeah, it's one of the things we look at actually, but more at the leadership level. When you're the maintainer, you can pretend you're blessed and you don't need to care about that. But yeah, the leadership level for the Kokkos project, that's something we've been actively looking at during the Exacel computing project, if you will. So that's where the Kokkos team really grew from just being a Sandia project. So back in 2019 to being a multi-lab. Like at the time, we just had Oak Ridge, Argonne, NERSC get involved all at once. From very early on, trying to start looking at how we can diversify and how we can, beyond ECP keep existing. And it's a challenge. It's always a challenge, right? One of the things that I don't have a good answer for you is hopefully, which is often a problem with our project, but hopefully you don't always have to promise only new shiny things. You can still carve some time for the maintaining of the project toward the project. So to give you an idea, at the end of the exascale computing project, we actually have software stewardship program, the money invested in it was just David could talk to it more than me, but was a fraction of what we had for the ECP project.
All right, thanks. One other quick answer, and there are a couple more questions, but we'll save those for later, I think. So the other that we'll cover right now is for the 50% bus factor calculation, how far do you find it's useful to look back at the contributions each year or each release or something else?
When I want to understand what trend my project had and whether I'm doing poorly, whether that bus factor is growing or not, I look at the past. So personally, I only go back to 6 years ago, but so you might want to go. You need to see to put it in perspective the pace of your project, of your funding, of what you're doing. I typically do it in years, and I try to make sure that the trend is right. But what really matters is today, right? So if it's good that you understand your trend, it doesn't matter that much if you were shiny years ago. If your bus factor is going to 2 or to 1, you have a problem.
Right.
Okay.
All right. Thank you. In the interest of time, we'll let you continue. We'll get to some of these other questions later.
All right. So let's get to the second core challenge to sustaining software. So the technical debt. So I'm sure you guys have all heard about that. Like here again, so a metaphor. And so the definition would be so that code or choices you make quickly today, cutting corner that will make your life easier just now, but will slow you down later. And the issue is that with the metaphor of the debt is that you're gonna pay the interest. You will pay it concretely in slowed velocity, so more bugs. Their code is less organized. Less like maybe you didn't write a test, so later you're less sure. You're gonna have more bugs. And so that's really one of the major challenges. So the problem, so the source for these things are really, we all work, we're not so special in HPC, so the vendors have the same problem, right? The thing is, so for us, we have deadlines for papers or for, you name it. You might have some of the other challenge is not always that you've necessarily cut corner. The hardware will evolve. Some requirements that you had in the past might not be relevant, and you need to evolve a bit your software. And the lack of refactoring, the lack of actually investing in paying out that debt can really make things worse. So the impact, as I said, development. So you see the cartoon, how long can it take to add a window, right? Your sponsor or and you look at them thinking, have you looked in the code base? Like, it's a mess. So that's the reality that you might have in some project. So it will slow the development, increase bugs, and will over time burn out your developer and maintainer. So yeah, the real thing is, so you need to prioritize refactoring, testing, and code review to deal with it. And so here are the lessons from my work in Kokkos. So I'm going to start with a first anecdote, which was a bit what hit us when I joined the project during ECP, which was so our mission was clearly getting ready for the new exascale machine. So we had to develop new backends. And so the problem was the architecture of the software looked like this. It had essentially demonstrated that the model of promising that from the single source code you can run on your laptop or on a cluster with CPUs or on NVIDIA GPU was demonstrated. But then everything had kind of grown and evolved to that point. And so there were many in the architecture, many centralized places in the code where every backend would come and just, if def away some different code. And it was okay-ish, when you had 3, 4, 5 backends. Today we have, that are maintained and usable. There's 10 backend, and we are working, in the background on new backends. That doesn't scale. And so the impact at the time was to even start working on these new backends. We had to, one of the challenges was also that you needed to have 70-80% complete backend before you could test anything in Kokkos. So that's when I started, we had to start, we had no choice but starting with paying out that debt and develop new incremental testing so we can even think of adding new backends. So giving you a little bit of an example where you can't really blame, it wasn't malice or anything from previous people, it's just things evolved. And if you don't take care of it, you can get to a point where before doing anything, you will have to pay the debt. And if you didn't manage anything, you might get to a point where you're better off abandoning your project and starting something else. And so the fix for all of this was, so we had to rethink on the architecture level of the software, having backends a bit akin to modules or plugins, to disentangle this choke points in the code base to avoid, massive conflicts with many people working on the same file at the same time. And we developed a series of incremental tests that can guide and validate new backends development. So you wouldn't, if you were looking at new architecture, which we do, occasionally there's always some experimental backend that are not necessarily public. You could know that you're on the right path and not just have to implement for a month before you can even know whether the massive thing that you did is anywhere close to doing the right things. Kind of disentangling, if you will, the different facility. So the lesson from this are really the proactive refactoring is an investment. Like in the future, we try to invest anywhere between 10 and 20% of our effort into just real pure management of our depth, like identifying problematic part and trying to strategize. It doesn't mean you just rewrite random things. It's really, that's your role as a maintainer, right? To know your code base and understand what parts might become your biggest problem, and you need to invest into fixing that. Okay. So another example that I would like to take, which is, I think, something pretty pretty common in HPC with the pressure we get to publish. Some experimental features. So we had several of them. I'm not going to name one specific, but that are pushed out for publication. With a lot of pressure of the deadline is coming. I need it in. And the thing is published, great. The person moved to the next shiny thing, and then later the publication is out, and maybe it was something that application are interested in using, and then you have the rest of the project of the developers and the maintainer that are left to salvage, fix the code with absolutely no incentive at that point. The classic, it's 90% complete, 100% broken, and 0% documented, and then the team is stuck with this. And so the lesson here is try to, push back against some of this short-term incentive. I don't really have a good answer on how we can convince our organization of approaching this thing differently, but as a maintainer, you really, really have to be able to step up and say no to some of these things. We've certainly become we learned it the hard way in Kokkos, and we've certainly become much stricter than we were in the past with these things. Okay, so that's it for this. And so the last thing that I want to illustrate through the view, the Kokkos view story is really another strategy, an approach that the Kokkos team had from, I want to pay respect to some of their original developer, because I think that was really the right approach. And that's one of the things that attracted me at the time. It's trying to offload some of this debt via, so for Kokkos, it was via standardization, but you could see it trying to offload some of your code, some of your debt to a bigger organization. So for us, so Kokkos offer a main data abstraction, what's called Kokkos View. It's an abstraction for multidimensional arrays that manages your allocation, on the device, on the host, and whatnot. And so for this thing, so in C++23, we had stood MD-span that was standardized, added to the standard library, which is an abstraction, a non-owning abstraction for data. And this thing is really, really born out of the Kokkos View abstraction. It took 9 years. It took 9 years from the first paper that was written by the Kokkos developer through the day it was standardized. So I was lucky to be there over the last half of it and to go through the finish line, but it was a massive investment from the team. But what it means is that then we can implement our view with some of the hardest parts and the implementation details that are not now offloaded to something that's standard. So standard, it means very good specification. It means that now the implementation is on your vendor, on your library implementer, the maintenance. So the reality is, as far as implementation go, Kokkos had the Kokkos team had maintained for the longest time the reference implementation, and in fact, we actually even contributed yet another implementation to LLVM. But now, there are 2 other implementation of MD-span, one in lib2 C++, the GCC implementation, and one by MSVC. And it means that for Kokkos, some of the more intricate part of our code in the future, in 3 years from now, when we will require C++23, we will be able to fully offload to high quality vendor provided implementation where the cost of maintaining it are shared amongst all the members of C++ community. So the lesson from here is that the ultimate debt reduction is if you can make one of your problem a shared community supported solution. Sometimes if your project is smaller, it might be convincing another bigger project to maintain it. Before I joined Kokkos, actually, I was on some other library, and we were smart enough to push some of this thing into Kokkos because the Kokkos team had way more means than us to maintain these things. Anyway, that's really the killer thing if you can ever do this. Okay, so wrapping up on the technical debt. The first strategy is really you've got to treat refactoring as a core feature for every single. So it means core feature just means that you really elevate it as a priority. You need to dedicate, say, 10%. You pick the percentage. It's not about gold plating your code. It's really about managing your debt. The second strategy is invest in robust layered testing to ensure refactoring doesn't break performance. Just treat your tests just like your main code, like invest in these things, maintain it. This is critical to be able later to keep adding features without having major regressions. And the third strategy was the last one I brought up. Oh no, actually, it's I'm telling you, by not, so I've seen many projects falling into this trap and saying, they adapt a minimum requirement and they don't move for 10 years. And then, they're totally outdated. So what we do in Kokkos is really, we adopt at a regular cadence, newer toolchain and standard. And it helps us, getting rid at regular interval of some of the kind of time the removal of some of the most tangled part of our code. So the key takeaway are pay down the principal if we want to stick with this metaphor. Don't wait for the crisis to fix the core issue. It might be too late then. Proactive maintenance is a feature. And the last note that I did is really the technical debt is not just avoidable. It's not always available, but you need to manage it. It's a hidden cost that will really impact the long-term sustainability of your project if you don't. Okay, that's all I had with the technical debt. Do we have questions, David?
Yeah, we do have one. Do you find it helpful to try and put real cost value on technical debt, or know of any project doing that? Or is there any other appropriate way to track technical debt for non-technical leadership?
I wish I could put numbers in some of these things. Unfortunately, occasionally you can point out at some things that should have been very, very simple, and how it's always, I guess you could measure how often you do simple things and you have fallouts. How many times you need to do bug fixes every time you touch anything. That could be one metric, but it's not great, right? Often you as a steward, it's very qualitative, right? You need to be able to keep an eye on how you see the guy in the center with everything entangled. How does your code look like this? And if so, what strategy? It's not about jumping and replacing your code, right? This is a risk by itself, replacing your code. It's really strategizing to try to make sure that at least all the things that you do not make things worse. And for some of this bigger problem, making a long-term strategy to get rid of them or fix them.
Mm-hmm. Thank you.
Okay, then I'll go to the last part of my talk, which is something you might be slightly less familiar with. That's in the C++ world is now under the Hyrum law. And so let me go back. So I wrote down again the XKCD, which if you have never seen is, it sounds like a joke, but it will ring the bell painfully to a lot of developers, I think. So it goes, I'm going to paraphrase it. It goes like this. It's kind of a change log, that's explained that some defect was fixed. The CPU is no longer overheating. And then sure enough, a developer comes around and say, you're breaking my workflow. You're breaking me. And you can look into detail. And so Hyrum was a senior developer at Google. And the expression is actually the Hyrum's law was popularized by another senior engineer at Google, Titus Winter, which happened to be for 5 years the chair of the core in the standard library that in charge of the library. I have this XKCD here because I saw recently that Hyrum was saying that this XKCD is mandatory when we go over the law. And so the law goes like this: with a sufficient number of users of your API, it doesn't really matter what you promise. All the observable behavior of your system will be depended on by somebody. That's these things. So this guy was senior engineers. They both moved on to Adobe at Google, and Google is in a better situation than us for this because they have control over all the code that they care about, right? It's a gigantic monorepo. They have teams of engineers that are in charge of managing the refactoring and they came up with this law because many times what should have been a mechanical replacement would break all over the place because people had accidentally ended up depending on something they shouldn't have. And so the problem in HPC for us will be that often you will have users that will end up relying on undocumented implementation details for tuning the performance or to do some subtle integration. They might do some assumption on your memory layout, or they might reach out even worse in some of the private implementation details. And then when this happens, and it's not malice, right? It's not like a developer wakes up one day and wonder what naughty thing he could do. But the problem is when you let this thing creep over time, that can make changing any internals in your code base like a nightmare. And so that's one thing since I've been maintaining Kokkos, that has been one of the major challenges I had to deal with. It's a everyday battle. So I'm gonna bring you like some of the anecdotes in our world. So to understand, so the daily grind is like you will have valid internal refactors or things that touch something. You look at the patch, it looks perfectly valid, right? And prove this, change, I added an argument here, change this, and then the next day you get reports in integration testing. Hopefully you have those that will tell you broke this code downstream. And these things, if you're really proactive like us, you might discover it at least the next day, but it can be a nightmare, right? You might discover it, you do a new release and you discover months after that you broke people, and this is panic on board, So the impact is like you will have forced reverts on things that were totally legitimate good changes, and you can over time create this kind of culture of fear around changing things that we do need to change. Like sometimes it might even be addressing some of the depth that you feel like you cannot tackle because you will break things left and right. So the cause for why did we get there on Kokkos? Well, some of it was kind of our own problem, our own fault. I'm going to bring a little bit of the history. So Kokkos was for a long time a sub-package in Trilinos, which is this also a Linux Foundation project, which is originally was at Sandia, and had many packages inside. And being a sub-package, we had some of our developers that had, former developers that had been in Kokkos and in a sub-package, and they, just also no malice, right? Sometimes not thinking about API boundaries between packages and just, I could use this thing that I know is there in Kokkos and just use it. And so our fault, as Kokkos leadership at the time is we didn't invest enough time clearly defining things like public versus private header. So one of the big crazes was I'm using when you're not dealing with it was that we had really never thought too much. I mean, we had a few public header, but we didn't really insist on what people should be using. And so you couldn't blame a user to think that if he's using Kokkos view, he should include Kokkos view or something like that. But in terms, what it made is that sometimes just even moving things from a file to another would break us, right? It was interesting times, right? And so the strategy to deal with these things is we really had to sit and think and build a formal contract with our users. So we actually ended up having to introduce that you, hopefully for your user, you've seen this in our programming guide, we have backward and future compatibility guideline, where we go over what's legal use of Kokkos and what's not, what promises. When we promise things to you, we want to make them very strong and tell you what you can rely on, but we warn you about things you should absolutely not do. Like, for instance, you shouldn't use private symbols. You shouldn't rely on anything that's private. You shouldn't. So we also had to spell out finally very, very clearly which header are public, which one are private. To get rid of this and get out of it, we had to go through a very long deprecation process. Over several years before starting warning people that they're using things they shouldn't, before we can actually start breaking them and tell them, you need to give time to people to move out of this. This is something that usually it takes a while when you're a developer to really understand that you can't just break people. It's not like there was a naughty developer that disregarded all the best practice. Often people who have written the code are gone for a long time, and there was no rule at the time. And often, who's going to see the failure? It's not fine. Often it's not Trilinus, or other dependency. It's some scientist somewhere else who just want to get his thing done and just happen to try to compose a newer version of Kokkos with some code that had bad hygiene and that can't get things work and might not even know what your project is. So that's why these things are really, really challenging. So I'm going to give you another good incident in the Kokkos world to illustrate some of this challenge. So one, it was something that happened about a year ago that I call the view of views saga. So the view, I mentioned it earlier, is our main data structure. And so at the time, it doesn't really matter the detail, but we fixed some thread safety issue that was necessary for this thing that was an ask by many users to have the ability to concurrently enqueue work from different threads. And just fixing this broke code using view of views, a pattern that in our programming guide, if you go, we explicitly tell people not to do it. And we tell them, well, if you really, really have to do it, here's the right way of doing it. So I'm going to go a bit fast because I want a little bit of time for question at the end. But the idea is that we had a hunch that we had isolated reports where we could always say, oh, it's a user fault, and easy fix. And so we did a slightly wider call for feedbacks than we usually do. And we discovered that the pattern was so pervasive across strategic application that we had to be pragmatic. So the strategy, sometimes you have to be pragmatic and adapt. So we immediately wrote a tool that you could run on the older version of Kokkos that would detect the semantic violation and warn people where these things happen so that they could, on the working version of the software, already see if they had the problem and get a feel for how bad it's going to be. We had to immediately, just before, these things were happening very fast before our release. So we had to add some secret, so it's not runtime, configure option to revert to the old unsafe behavior as a fallback. And ultimately, pragmatism, we had to invent new view semantics to officially start supporting the use case that this use case that had become so common. At that point, the user is defining your API, not you anymore. Your API, not you anymore. So one of the strategy, knowing when to roll back. Like we have over the years I've been there, several times I had to roll back optimization. Places where the developer would really happily remove some fences, so less synchronization, more performance. When we discovered that the cost of fixing the bad code was too high. And so the lesson for you as a maintainer is that the API is what users actually depend on, regardless of what you documented. Okay, so let me wrap up that section. So strategies, when you write your functions and your APIs, really define, think very aggressively what's public, what's private, and force it via namespaces, have an import of detail namespace and hide things. These things are really challenging for C++ template library like Kokkos. Think very carefully what headers people use or modules, and so like do it from the get-go. The way to deal with these things is you should have some formal deprecation policy, and with hopefully a generous time for your user to adapt. For us, it can span over years before we can remove some stuff when we discover that it's difficult for people to migrate out. And invest. The other one is like maybe the most important one, invest in integration tests with your downstream projects. You want to catch these problems as early as possible. Kokkos massively invest in that on likely tests with Trilinos, but not just them, with many partners. So the key takeaway is, changes have a cost, and you need to try to minimize this cost by as rigid as possible defining the contract and providing a clear transition path for your users. David, I have one more slide after that.
Let's do the one more slide.
Yeah. Okay. So wrapping up from the talk, so the path to sustainable HPC software is really managing your best factor, know your single point failures and try to decentralize knowledge. Pay down the principal, the debt, try to refactor proactively. Define your contract very carefully, and because you will have to manage this implicit dependency on your software. So, and the last word is really sustainable software will require proactive stewardship, not just heroic coding. That's it.
Well, thank you very much, Damien. And we are very close to the top of the hour, but if Damien can stay around for a couple of minutes, we can try to get a few more questions in on the record, and otherwise they'll be in the notes. So I'm going to take these a little out of order. How do you typically accommodate user expectations created by Hyrum's law? Namely, what percentage of time do you revise the contract, say no to a complaint, or find some middle ground?
It's case by case. We over years with Kokkos, we have like different categories now. The thing is, we've become very proactive. Like often we will even back out changes before people even discover it, because anything that I will recognize or senior developer will recognize as risky, we will do extensive. Sometimes we will demand at the moment of the review extensive searches downstream to know the impact. And then it's tricky. Sometimes you just can't have the nice thing because that would break legitimate code that has always been legitimate, and we will just sit on the potential improvement because in the end, we don't want to fracture the community and let people to the side of the road. So it's a challenge, and you have like things that are where you can't possibly have correct software if you use a pattern, correct code. These things we will break, and we will. So we do release briefing at each minor release. Kokkos will hold an hour to an hour and a half meeting, so where we go over the release notes and we call out every single. So we have bug fixes, but we have another rubric that explicitly calls out non things that could impact code, and so we classify them. We explain when we decide to proceed. We explain to people what changed, how they might be able to observe it. We tell them how they should fix it, and we explain to them why we did it this way. And so the criterion, usually the must do, is your code can't possibly be correct, then we will do it. Other than that, it's often being pragmatic based on the surveys that we've done and how widespread something is.
All right. Another question, would you recommend rejecting half-baked features completely, or could an experimental namespace, for example, be a solution that did not give any guarantee to downstream users?
You can't be entirely strict, nothing. But keep in mind if you're about to accept something, you've got to ask yourself this kind of question. Is this thing visible? If you're using C++, do you get this naturally when you include anything from, like, if I do Kokkos core, do I get this feature? Then if so, yeah, you better be super strict, because these things, it's not like you put it on the shelf and people use it or not. If there's a unforeseen problem, it might affect all your users that don't care about it. So if you put in place a real mechanism and you're careful with it, so that it's to guarantee that it's an opt-in, and you really clearly documented what promises you do to your users, that they have less promises with experimental, then yeah, you can loosen a bit your rule, but be careful. Don't just accept anything in this thing, because in the end, it's going to become baggage.
Mm-hmm. Okay, I'm going to go back and try to grab a couple of earlier questions. Do all the issues you raise happen only in university and government projects? Is industry more efficient in planning ahead to manage these problems before they happen?
No, they're not. I mean, you always think that it's greener elsewhere, right? Christian usually makes fun of me, my colleague, saying that nothing, like I complain too much and nothing is good enough. The reality, so a lot of us are, now decently senior members in the C++ committee, and we interact with many vendors. We collaborate on some of this feature with them. And now they have, they don't have papers, but they also have ship the feature, right? And some people don't stay and don't care, and so they have the same problem, and they're certainly not necessarily much better than we are with this thing. The one place where I think people are much stronger than us, but it's because they had no choice, is the standard libraries. And it really comes down to the sheer number of users that hammer your interface. And some vendors might, something they will end up having better hygiene just because they had no choice. They upset I mean, it can become a risk for their business model, right? If they keep breaking their users every time they release something. But in general, my experience is they have they struggle with the same thing as us, and it is just slightly different things that leads to it, but they have the same problem.
Mm-hmm. And so a couple of questions that go back to the first portion of the talk. Are there any guidelines on how to do the documentation? Are there templates to follow, review criteria? the rationale for decisions is important. How is documenting the rationale enforced?
Um, that would be a long discussion. I can tell you how we do things in Kokkos. It might not necessarily be always the right thing for you. So in Kokkos, we went the route where we have a programming guide that try to focus more on teaching and bringing concept and intent to users. When you go into a real reference documentation for some feature, there's a balance, right? I mean, the documentation, and that could be another talk, right? The documentation is also code, right? You can't just dump garbage that you don't take care of. You need to, as you manage your code, the same way you manage your code base, you need to manage your documentation. Hopefully they live side by side, so they say, in sync. It's a balance, right? You need to be sometime to the point, and sometime you will need to something will be besides too far. We in Kokkos we have too little, in my opinion, design document, but we usually don't put them in documentation. It's more an internal. Sometimes they might be in code. Sometimes they might be in text files that are added in somewhere in the code or internal documents. But it's not always a good fit to document too much in your API reference. You need to read it yourself with new eyes and see whether it becomes too heavy. One thing we try to do is when we break people or when we change things, and when over time we discovered we really have to write these things down, we force ourselves now more and more to write it down. Why did we do that? So that users understand that we don't just do things for the pleasure of breaking them. Yeah.
All right.
But yeah,
And
it's a tough question.
yeah,
So
absolutely. One last question then. So referring to the bus factor issue and trying to broaden, do you have strategies which have worked for you to entice people to take on additional responsibilities within a project?
so yeah, I mean, I was an outsider at some point, right? You saw, even though maybe I didn't spend enough time on it, my journey into Kokkos was I was a user. I learned heterogeneous programming and discovered Kokkos around the same time. I very quickly became a contributor, joined the developer team, and very quickly then ended up being maintainer. But I think that some of the important strategy is you need to carve some room for new people to come and become your equal. And it's not a model where you're just going to be the king and have everybody just do the little labor around you. You need to make it enticing for people to come work with you. And from my experience working on some other open source project, contributing to standard library implementations, one thing that can really help is documenting your processes. And we're working on that on Kokkos. We can certainly do better. So I have a governance that clearly define the different roles of developers, maintainers, leads of this, of that, explain how things work, and try to explain responsibility, what's the path forward, how did you get from one to the other. So really trying to have your future contributor feel like it can become also theirs. So Kokkos, and that would be for another talk, but you see the HPSF logo. It's not just a Sandia project. It was important to grow that every other parties could see that they also own a little bit of it. It's no one's at that point. It's a community project. And so making it clear to people that they also own it in my experience, is a way of making it more interesting for them to get involved.
Great, thank you so much. I think we've exhausted everything. I'm just scanning down. Yeah, so I would like to thank you, Damien, very much for an excellent talk. I'd like to thank everybody in the audience for participating, and I'd like to give a special call out to whoever is the anonymous lemur on Google Docs who has been helping us capture Damien's responses to the questions live. It's really fantastic. Thank you all very much. This is probably the last webinar for this calendar year. I don't think we'll have anything in November. December, I'm on vacation, and we'll restart in January. But keep a lookout for announcements in case things change. Thank you all very much. Take care.
Thank you.